This is Dr. Dinesh Kumar Koli from SIRT College, Sejpur, Bhopal. And in this video, we will discuss about reheat cycle, which is the part of modified Rankine cycle. So, the reheat cycle, it is a part of modified Rankine cycle. So, first you will understood what is the reheat cycle. So one of the problems in increasing the efficiency of the ideal Rankine cycle is the moisture content of the steam at the final stages of the expansion. It means when the expansion of steam takes place in the ideal Rankine cycle, but in the final stages, there is the moisture content present because this moisture content is harmful for the turbine blades, which is causing erosion and corrosion of the turbine blade. So it is not permissible. So the solution for this problem is a two-stage turbine with reheat in between. It means the steam is reheated between two stages turbine. The one is called as the HP turbine and another is called as the LP turbine. HP means high pressure turbine and LP means low pressure turbine. So it is the solution to the excessive moisture problem in turbines and is commonly used in actual steam power plants. The sole purpose of the reheat cycle is to reduce the moisture content. The purpose of this is to reduce, to minimize the moisture content of the steam at the final stages of the expansion process. Now, what is the difference between ideal Rankine cycle and ideal reheat cycle? So, the difference between the simple ideal Rankine cycle and the ideal reheat cycle is that the expansion process occurs in two stages. It is the mainly difference. It doesn't occur in single stage, but it occurs in two stages, and between these two stages, there is the reheating of the steam. In the first stage, the high pressure stage, in which the steam expands isentropically to an intermediate pressure, and then the steam is sent back to the boiler, where it is reheated at constant pressure to the first inlet temperature. So this is the part which is done in the HP or the high pressure turbine. In the second stage, it means in the low pressure stage, the steam expands isentropically to the condenser's pressure. So in this way, we can see that the expansion of the steam is done in two stages. Now here you will see the diagram, which is the schematic diagram. So here you can see the one is the high pressure turbine is this, and this is the low pressure turbine. Okay, so this is the boiler which is generating the steam. So boiler which is generating the steam. Now this steam first it is sent to the high pressure turbine here. This is high pressure turbine, and the isentropic expansion takes place in this high pressure turbine. So from point 3 to point 4, which is showing this is the point 4 and this is the point 3. At point 3, the steam enters the high pressure turbine and isentropic expansion takes place. After isentropic expansion, because the moisture content is there slightly, so before reaching is to the more moisture content at point 4, the steam is taken from this high pressure steam turbine and then it is passed through this reheater section, which is from for in the boiler. So here the steam is reheated. Then after reheating at point 5, the steam is now enters the LP turbine. This is the LP turbine or the low pressure turbine where its isentropic expansion will take place. And then after expansion from this LP turbine, the exhaust steam at point 6 is passed through this condenser. So the condenser is the unit in which the heat rejection takes place by taking the heat from the exhaust steam by with the help of the cooling water. Then this cooling water, which is taken from this condenser, and with the heat of help of the feed pump, it is recirculated to the boiler. So in this way, we are seeing there are the two turbines, HP turbine and LP turbine, and between these two turbines, this is the reheater section. Steam is reheated. The same is also shown here on the TS diagram, temperature entropy diagram. So here you can see this is actually 1 to 2. You can see here at this point, it is the pump work. The pump feeds the water to the boiler from point 2 to up to this point 3. This is the part called as the heat addition in the boiler. This is QA part. So boiler in which heat is added and it produces steam with the pressure, high pressure, and at point 3 steam enters the high pressure steam turbine. So from point 3 to point 4, this is the isentropic expansion in the HP turbine, high pressure turbine here. This is the HP turbine. Here the expansion takes place from point 3 to point 4. Then we will see from point 4 to point 4 to 5. This is the part in which the steam is reheated in the boiler, which is shown here. You can see this part. This was the reheating part, where the steam is coming from the HP turbine and passing through this reheater section for the reheating purpose before going to the LP turbine. So this 4 to 5 is showing the reheating of the steam, where at the same pressure the heat addition is done and the temperature is increased. Now here we will see that at point 5 the steam enters the low pressure turbine and this isentropic expansion takes place in the point 6. So this is the expansion of steam in LP turbine. This is a low pressure turbine. So what we are going to see here is that we are seeing that we are obtaining the work in both the turbines. And at point 6, the exhaust steam is passed through the condenser where heat is rejected. So this is the heat rejection is QR. And then the water obtained or received from this condenser with the help of the pump is recirculated to the boiler. So in this way, we are seeing that the expansion of the steam is occurring in two turbines, high pressure turbine and low pressure turbine. And between these two, there is the reheating of the steam. So the main advantage of this reheating is we can say the reheating is done between two stages, and it is avoiding, it is decreasing the and moisture content is very less, and because heat addition is being done here additionally, so definitely it is also increasing the efficiency of the cycle. In our next video we will discuss about binary vapor cycle. Thank you.